So you've made some working patches now in Macs, and you've even performed with them using the controls available on the screen, the graphic user interface, or the GUI. But you've probably noticed some frustrations that graphic interfaces aren't always the best thing to use. For many performance situations, you really need to have the controls, the buttons, the sliders under your fingers so that you don't miss. And think about playing video games on a game with a gamepad or similar controller. The buttons are always already under your fingers. You don't miss. There's not really such a thing as a wrong note. It's more about your timing and things like that. On a computer keyboard, you can miss. You type wrong letters all the time. On the mouse, well, your pointer device is under your fingers all the time, but you have to move the cursor to where it needs to be, and so you can miss that way. Also, you have many fingers that can control many things at once, and so all of these things make it a very attractive option for building a performance. If you can add external control in some way. And so this includes your typing keyboard and your pointer device, whether it's a trackpad or a mouse or a trackball. But it also includes MIDI controllers, like a MIDI keyboard, and it's likely to have keys, but it may also have sliders, knobs, and pads you can push. But this can also include game controllers, and when you get more into the electronics of it, you could deal with any sensor that senses any physical phenomenon like temperature, bending, pressure, rotation, orientation, tilt sensors, things like that, and convert those into data that could be controlling your patch. So first I want to look at the different kinds of controls, because this isn't necessarily surprising, but I want you to start thinking about the strategies behind what kind of control would be good for what kind of artistic function in performance. And so there's a continuous slider, and that's nice because we could have a virtual continuum of values coming out of that, but we're always stuck going from one position to the other with smooth transitions in between. That may not always be desirable. And so sometimes it's better to have a button for each thing, but that means we have to have a button for each thing we want to accomplish, and that could end up with a bunch of buttons. Something that may be attractive for some performance situations is a combination of these things, where I dial in the value that I want with a fader, and then I hit a button to actually send that data in. That's kind of how a guitar works, where our left hand can move up and down the neck of the guitar, and then our right hand plucks the string and commits to making that note sound. Other times, knobs can be useful. They're nice because they require less motion, a smaller motion, a twisting motion. But sometimes knobs are, you may have noticed on more recent devices, knobs go all the way around. They spin endlessly. That's called a digital encoder. And really, it's not sending absolute data as far as where it is on the dial. It's sending information about which way it's spinning. And so, I moved down a little bit. I moved down a little bit. I moved up a little bit. And then the software keeps track of the value that that's supposed to be. And that can be nice in certain ways, but also that means encoders don't always have the visual feedback that you need to see. I can look at this knob and see right where it is right now. As far as buttons, you might be able to get a toggle switch out of something. So if I hit it once, I'll try to do this loudly so you can hear. I hit it once and it changes state. I hit it again and it changes back. Many controls are momentary switches. I hit it and it sends out a 1 or something like that, and then when I let go is when it sends the 0 or it's a default message to return to let you know that the button isn't being touched anymore. So this is a toggle switch. This is what a momentary switch is like when I hit it right. And you might also have some switches that just send on messages and nothing else. And they ignore when the button is being let go. Then fancier controllers, especially ones geared toward music, have a combination of controls. We have here on our virtual piano keyboard an array of switches, buttons that we can press. They're momentary buttons like these. And so I can say I want that one or that one or that one, and it'll tell me what note I picked, which button number I picked. But it's also giving me this other information called the velocity, how fast I actually hit the key, or in this simulation, how high on the key I press. But we can see when I hit something softly, I get a low velocity number. When I hit it very fast, I get a high velocity number, and when I let go, it turns to 0. So this kind of controller is a step up from these, because it says not only what switch did you hit, but in what way did you hit it? How fast did you hit it? Okay, so I'm going to show you some communication protocols that we can use to get many controllers sending data into Macs, so we can connect these to our patches. And the main idea here is that any number that we can get into the computer from a controller, we can map that to any part of our patch that needs a number to answer a question. How loud should this be on a scale from 0 to 1? What frequency should this be on a scale from 20 hertz to 20,000 hertz? What's our center frequency? What's the slope of this filter? Anything that can be quantified, we can take a control and shape the numbers coming in so that they can map to control that parameter of our patch. So go back and think about the things you've seen built in class before, the things that you've built yourself, and think about the opportunities where you could use an external controller to control some of those things. All right, so first, let's see, these fit in a particular order. I want to go introduce them in a different order. You've probably remember seeing the key object in class before, and what it does is simply report the ASCII value of any key that's pressed. So here's the letter A, there's S, D, F, and actually there is it does make sense. So A is 97 in this ASCII system, B is 98, C is 99, and so on. Capital A is, capital letters are yet different. And so we often use this with the select object. The select object lets us give it any of several arguments, numbers or values to watch out for. And when that value comes through, let's see, this one's looking for 22, so if I give it 21, nothing's going to happen. But then when I give it 22, there we get a bang. So this is watching for anytime 22 comes in, and it'll send a bang right out here. I could give it other arguments, and it would be watching for other values to come through, and I would have outlets that would send bangs to alert me to those things happening. So right here I'm using it to watch for key number 32, which is the space bar. It's going to bang this message that has a 1 in it into this toggle, which makes it change states. It makes it turn on. Sometimes that's enough. If you have presets, for example, that you want to trigger, there's no on-off about a preset usually. It's just go. And so maybe the key object is well suited for that. Sometimes we want to know when we'll let go of the key as well, and that's what the key up object is for. And so it works just like the key object, but it reports what key you let go of. And so still, again, I've got a select object looking for me to let go of key number 32, and when I do, it's going to bang this 0 into that same toggle there. And so you can see I've built a virtual space bar, basically. So everything I do on the space bar gets shown up here. And so I could do that with any of the keys and then control many things, several dozen things with just my hands on the typing keyboard. Now, probably the next most most useful or maybe familiar is using the MIDI protocol, Musical Instrument Digital Interface. And in this case, interface means, it's really not, it's not a piece of hardware, it's a protocol, a way of talking. And so these devices can send data back and forth, and they've all agreed that, hey, when I send this kind of number, the first number means the pitch, and the second number means the loudness, things like that. That's a protocol. And so there are a number of ways to get MIDI information into your patch. Here I'm using the MIDI in object. That's MIDI-IN. And if you double click this object, when your patcher is locked, of course, double click it, and then you'll see a number of MIDI input devices, places where you can get MIDI input from. And you can see that you can receive MIDI from other Max patches. You can also send MIDI from a Max patch into any other program that can accept MIDI commands. Let's see, and I have my Korg microcontrol plugged in here, and it's offering a few different ports here. And so there's always a little bit of exploration when you're exploring a new controller. So I'm going to be modeling this for you. So that seems odd that one's labeled MIDI in. That looks like it's MIDI in to the controller. So I'm going to, I'll try selecting it and press some keys. Nothing, I'm not getting anything there. Let's try port A. Oh, we see some activity there. I'll wiggle a knob. Oh, I'm not seeing anything. So that's because we're not looking for the right things. So what we're doing here is we're using the MIDI in object and then the MIDI parse object, which is breaking out all our MIDI signals into the various types of messages that can come out. Note on and off messages. There's also a place to send polyphonic pressure. I'll explain that in a second, but most devices don't have that. There's also control change information. These would be your knobs or sliders or buttons. There's also the ability to send a different kind of control called a program change. That's usually meant to change settings from the piano sound to the organ sound, for example. Pitch bend you've seen, and it kind of works in a standard way there between 0 and 127, and usually snaps back to the middle. There I can get a controller working there. And aftertouch refers to how hard I'm pressing on the key after I've pushed the key down, but before I've let up. So this is while I'm holding the key. Some devices will let me push harder on it and get more information out. And it looks like this keyboard doesn't offer that. That is a fancier feature. So back to polyphonic pressure. It's a polyphonic version of aftertouch. It would actually say aftertouch is one value about how hard I'm pressing overall. Polyphonic pressure would show how hard I'm pressing each key, which could allow for some really expressive control if you use it right. So let's see here. This is the basic guts of it that you're probably going to want to have in your patch. But like I said, there's some exploration. You have to get to know how this controller is set up. And so there's a useful tool here under the Extras menu called MIDI Tester. And I can open this up and update a list of available devices. And I've got all the possible controls already built. Here, this is just a patch that's half built. Here I can see I should be able to see every MIDI message that the controller is sending. So if I push, let's see, this should be middle C. I can see it on the screen here. I can see it's note number 60. I can see here I'm pushing it very hard. There I'm pushing it very quietly. You can see the note offs happen when I get a velocity of 0. Let's see. Yeah, nothing on aftertouch or polyphonic pressure on this keyboard. I really want to do something with this slider. So let me wiggle this slider and see what's changing. This is another lesson. I'm not seeing anything when I change this slider. I saw something when I changed that, but we'll come back to that. So let me try one of these other ports. Aha, there it is. For some reason, this keyboard by default is set up so that the note messages go to one port, and the we call these continuous controllers messages go to a different port. So be sure to remember you're in an exploration stage and see what happens when I do each of these things. Here's a control for the pitch bend, and we can see that value coming in. Okay, so we can use MIDI tester to see what things to look for. Like, for example, I'll go here and I say I want to use this slider for something. Okay, this is controller number, let me use this one. This is controller number 7, and here's its value. Okay, so if I go back here and build my patch, I'll set it to port B in this case, and I'll expect to see information coming in that says that controller number 7 is changing values. So it's kind of like a note on message. It says which one and how much. The first number is controller number 7, and the second number is how much is it. So I'm going to use, in this case, the route message object here. And just like select, I can give it a number of arguments. This is things to watch out for. But whereas select will just send a bang once it receives something, route expects there to be more information after that. And so I like to think of the route object as kind of like the person in the mailroom who looks at the envelope or the to field at the top of a memo, and then sends the guts of the message to the person that it's supposed to go to. So now it's looking for number 7 as the first member of this list, and then here this outlet, it will send the rest of that message. Okay, so now I'm changing controller 7, and we can see there I've got a number that corresponds to the position of this slider. Okay. So that'll address a wide array of musical instruments that are using the MIDI protocol, but there's a wider world out there of controllers and a bit of a wilder world out there, and many of them fortunately use another kind of a protocol called the HID, Human Interface Device Protocol. So most USB controllers do this. This isn't a guarantee that every USB controller does. It's up to a manufacturer if it's going to go by this standard. And as you'll see in a second, it's not as well defined as the MIDI specification. But it's all centered around this HI for human interface, or HI object here. And I always find it useful to open up the help patcher and steal some of these commands out of here. So let's look at the help patcher. You can see there's a lot of things in here. What I want to do is copy this, and I'll hold down shift and click this, and I like a menu and a poll, and so I could copy these things and then make a new patcher and paste them in, and that way they're all connected. I don't need them now because I've already made that. So once I do that, I can click this menu message in here, and it will update this menu object with all the controllers that it can see available. And oh, that's interesting. My microphone is offering itself as a controller. I wonder what it can do. Okay, then I need to give it a message. So I'll need to pick which control I want to use. Let's see what if my trackball gives anything. It doesn't look like it. So here's something that can. I've got a gamepad. Oh, that's right. I forgot one thing. You'll run into this too. Okay, so I selected it and it's not working. I don't see anything. Well, this object is very conscious of saving processor power, and so it's not going to be looking all the time to see if your device has changed. We need to tell it how often to look, and so we give it the poll message with, for example, the 10 milliseconds, and now it'll report a value every 10 milliseconds. So now we can see data coming through, and it looks a lot like a control message in MIDI. Okay, so, and we can use our route object to route them out, just like we were using for continuous controllers. But remember, it's exploration. We've still got to figure out what is being sent when I use each control. And so we have another useful utility up here in the extras menu called Hi Tester, HI Tester. And so that'll open up this little window here. And it's basically got this part all automated for me. So I can come in here and let me pick my game controller. And as soon as I start pressing controls, let's see, I'll hit the A button, nothing's happening. Oh, I forgot about polling again. I always forget about polling. Don't forget about polling. We have to actually turn it on. Okay, so this is just doing this. This is just a fancy version of this. So it's starting to poll. Now I'll hit the A button. Ooh. Okay, I'm still not getting anything out of this controller. So what I'm going to do is try one more thing we should do. I'm going to quit Max. I'll unplug my controller and plug it back in, and then restart it. Okay, so now I'll try the Hi Tester here. I'll select my device, turn polling on, and look, there it's working. So don't give up if you don't see controls right away. For one, remember polling. Remember to actually select your device. But if you still don't see anything, make sure that you don't have another HI object that's trying to poll that same thing. It'll only connect to one device at a time. And only a device can only connect to one Hi object at a time. And also just try quitting Max and plugging your controller in and then restarting it. So now I can see this menu of data automatically populating as I'm hitting the buttons. And so the more buttons it sees, the more it sticks and other controls, the more it records here. So let me find one of these. Here's my directional pad. I've got a button for down, and so it happens to be number 4, and it spits out a 1 or a 0. Left happens to be 5, right is 6, up is 3. And notice that's a peculiar thing with directional pads. It's sometimes difficult to just get up without also getting up and left or up and right. That can be a bug or a feature depending on how you use it. Let's see, here's an analog stick, they call it, and moving it on the vertical axis here, it moves between, let's see, the lowest I get is 1 and the highest I get is 67 for some reason. Oh, I also see that it's not always the same when I go up to the top. Also notice it's very hard to move the vertical axis without also moving the horizontal axis. Here it is going from left, which spits out a 2, and all the way right spits out a 67. So you'll need to figure out how these controllers are working, and this will also let you notice how how tied together some of the controls are, and where it may make it difficult to control one without controlling the others. So you can do this for your initial research, and then you can go into your patch and say, I'll select that trackpad again. I'll have it make its menu, and I'll select it. I'll turn polling on, and then let's see, the down key was number 4. So we can see 4.1 or 4.0 coming in, and so I can map that to something. And whichever controls I want to watch for, I put them as arguments in my route object and connect them where they need to go. Of course, we're probably going to want to do some things to shape those numbers, but we'll get to that. So notice my trackball showed up here. My computer's trackpad shows up a few times, which is curious. Okay, 4 times. This is why you need to explore. They're all built differently. But in the case of your pointer device, it can be nice sometimes to have an object that doesn't require this particular kind of research, so that it only works with that particular controller, that particular mouse. Sometimes you might want to make it so that someone could take your program and run it on their computer without having the same exact mouse, and still be able to use their pointing device. So for that, we have an object called mouse state. And I just put it here so that you can open up the help patcher, because it shows all the everything that we need to know about it. Here it takes a poll message just like the hi object does, and it's got different outlets for each thing, just like MIDI parse does. So here we see it puts out a 1 or 0 for the state of the button. Oh, but it's only tracking the left button. If we have more buttons on our controller and we want to track them, then we have to go back to high. But this is for standard mouse operations. This can work pretty well. These number boxes are showing the horizontal and vertical position. And similarly, it's kind of hard to move vertically without also moving horizontally a little bit. And finally, these two show the delta, the difference between the difference in, for example, the horizontal position from one pole interval to the next. And so if I'm moving very slowly, we see very slow numbers. And if I'm moving my mouse quickly, we'll see it bursting up to high positive numbers or low negative numbers that are farther from 0. This could be useful. You could calculate this yourself from here, but here it is ready-made, so that might be attractive for you to use. Let's see. I've also thrown this in here. Some of you may be familiar with a communications protocol called OSC, Open Sound Control, and it happens to be a communications protocol that uses UDP packets over network connections. If you happen to be familiar with that, so this is great for sending information across computers, whether they're wired together on a network or they're across the world. But you can also send information between programs on the same computer. And so, for example, I have a program called Osculator that I use to connect my Nintendo Wii remotes, and then it spits it out as OSC messages, which Macs can pick up and use. So let's see. And so now this is showing me, okay, there's the address of this particular Wiimote, and it's showing me all the different controls that it's seen data come in, and it's not showing what data is coming in, but it's just showing a little light when something comes in. That's just how this particular program works. It's called Osculator. I believe it only runs on the Mac operating system. There are similar things for other operating systems. And so anyhow, I wanted you to see this this particular device has its buttons and controls. Here's the accelerometer labeled in this particular way. So this little patch that I have included in here for you, let's see how our data is coming in. We have to set it up to see what port to use, what port to look for messages on, and then when data comes in, and we've got a lot of data coming in from the accelerometers. So here's Wii number 1, the accelerometers. PRY is pitch, roll, and yaw, and it's showing a series of 3 numbers all at once. So what these objects are doing are slicing this message up so that we can send it out to a receive that has exactly this name. And that's what the forward object's doing. It's like a send object, but it lets me tell it who to send it to or what object to send it to. So for example, I have a receive object over here, and it's got this same name. And so now I've got a control for, let's see, the pitch, the up and down pointing. So if I point down, I can get something closer to 0. I point it up, I get something closer to 1. Notice it's hard to get those absolute maximums. Also, it's very hard to hold still. Now it's sitting on my desk, and I still have some noise in this sensor. So those are things to look out for. You might not all be able to use Osculator, but I wanted to mention this in case you already had the ability. and wanted to incorporate it into what you do in this class. You might also find mobile applications for your mobile devices, phones and tablets, that can send OSC information. And basically, both your computer and your mobile device need to be connected on the same network. And as long as the firewall isn't blocking the that particular port, then you should be able to get data into your computer just fine, and you could use your phone to control your patch. That's been a nice feature we've had for quite a long time. Okay, so we're getting a lot of integers. You've noticed, even from my controllers here, values between 2 and 67. Not always regular kinds of round numbers. For MIDI, the values are between 0 and 127. If I want to use that to control volume, I need a value between 0 and 1. Well, first of all, remember you can always do the math to map those numbers. And it's healthy to do that, to do the math. So, for example, if I have something changing from 0 to 127, and I want to have it changing a control that's looking for something between 0 and 1, well, there's a number of things I can do. There's a divide object, and really I just need to divide it by 127, and that would get me there. So if I get up to 127, that'll give me 1, all the way down to 0, and that's no surprise. We could also do this in an export object. If you've noticed that happening in class, and so that would look like that instead. But what about my slightly wonky analog stick on my controller here? Let's see. Is it still? Let's see. This is number 20. So let me change this one that's already connected. So it's looking for number 20. And so this is the vertical axis of my trackpad. And this is quite old and been knocked around a bit. So maybe this is why, but controllers are just like this. Oh, there's a 1. Okay, so let's say I'm getting values between 2 and 67. Well, I can't just divide. I need to do something else first. So think about it. I've got values between 2 and 67. This is another time when we remember the proto-number theory aspects of our 7th grade math, and we remember that 0 and 1 are special numbers. We remember things like the identity operation, or the identity value for each different operations. And so what I'm going to do is, let's see, I've got a value between 2 and 67, and I am going to subtract 2. Or maybe, to be a little bit more efficient, I'll add -2 to my processor. That will give me a value between 0 and 65. Okay. Now that it's on 0, I can multiply this by anything or divide it. And I'll just divide it by 65. And that will give me a value between 0 and 1. So anything times 0, or 0 divided by anything, is going to be 0. So the strategy here is handle your offset first with adding or subtracting, so you can get 0 pinned down, and then divide it by usually the highest number there, and that'll get you a value between 0 and 1. If you're working the other way, if you've got a value between 0 and 1, and you're trying to get, say, 2 to 67, or maybe 20 hertz to 20,000 hertz, then you would take your 0 to 1, you would multiply it by something first, and then that would give you a bigger range starting on 0, and then you add the bottom number, and that will give you that part. So let's see what this looks like here. We're going to take our number in, and we'll, just for clarity, I'll subtract 2, and then we need to divide this whole thing by 65. So I'll use parentheses, and I'll make sure that it knows I'm dealing with floating point values here, so I don't want it to truncate. And so now my horizontal number is coming in here. Now, what if, I don't want it to accidentally spit out a 0 every once in a while. So I can use an object called clip, and I'll say, hey, clip this to don't go any farther than 0 or 1. Sometimes it'll stretch a little farther, and we don't want that. So clip allows me to set the safe values for my control. I could also put the clip up here and say don't send anything out below 2 or above 67. So I would say clip to 67, and it would clip it at this end instead. Okay, so let me clear these notes out. These are the first steps in data conditioning. Now, what I was doing here is also duplicated in this object called scale. It's important to know the math behind it, and it's important to try to use the math behind it. Let's see, scale doesn't clip for you, but it will let you put in a minimum and a maximum input value and specify the minimum and maximum output value. So I could take controller number 1 from MIDI, which is going to be a number between 0 and 127, and select the right port, and there I've got my 0 to 127. There it is. And it's scaled to a range of 0 to 1. For more data conditioning, it's not necessary, but for this assignment, but you're going to want things like that later. And we'll spend more time with this in coming units. But I've got a patcher here called the data conditioning gallery. So make sure your patcher's locked, and you can double click it, and it opens up a large gallery of data conditioning techniques. So play with this. There's one input here. I've got this slider that's going between 0 and 1, just as an example. And we can see all the different kinds of information I'm getting from these things after each of these different techniques. So here I am showing the raw data between 0 and 1. Here I've between -1 and 1. Here I've scaled it to a range between 0 and 1. So see 0 and 1. Here I'm doing some smoothing. So you can see these are a lot smoother. And so if I make jagged changes, there's jagged changes. Here's much smoother. This is a similar state with much more smoothing happening, which means maybe I lose some subtleties, but I get much smoother results. So this is where you're starting to tune your data or condition your data so that you can get the kinds of control that you want out of it. And so here we're setting thresholds and counting numbers of times that things happen, or waiting until I've been over a certain value for a certain amount of time. These are all different ways that you might want to use an external device to trigger something inside your patch. So feel free to go shopping in here. If nothing else, you'll probably just need to use the scale object, and do try to refamiliarize yourself with the arithmetic that's going on there. So your goal for the controller assignment is, you've got a blank patcher, and your goal is to make a patch from scratch and perform with it. And you need to use at least 3 external controls, not separate controllers, but this knob, this button, and that button would be sufficient on one controller. But you can use multiple controllers as well. Use as many as you want. I want you to see at least one that is a toggle or a bang, some kind of button, and at least one continuous controller, like an analog stick or a slider, mouse height, or the delta value. Anything like that will count. And so you're going to be building this patch from scratch and drawing on things that you see here, or in the synthesizer demo I'll show you in another video. But Also, just draw on things from your previous assignments or patches that I've made available in the notes. You're not learning new audio processing techniques or video processing techniques. This is just about how to control those things. So it's fine to revisit something you've built before and now think about a better way to control it more expressively. Okay, so we'll close here and look for the video on synthesizer demos that you might want to use your controller to do something that you haven't done before.